it's 7 o'clock, so we may as well press on with proceedings. So yeah, just to recap on the comet, because things look like it's going to get really exciting, and I think Alan's going to tell us a little bit more about it later. So here was it when it passed through the field of the Soho probe, observing the sun in the center, of course, and then you see just how much brighter it is when it goes off the field of view as it was when it came in. So we was expecting great things, but this was about a week before it's closest to the sun. And then, as you know, I was lucky enough to catch it a few mornings ago, definitely naked eye, so you've got to get out and see it because it's definitely worthwhile looking at. But I was struggling with clouds and I had to go a few miles south, and by the time I got there it was really bright sky, so I missed it at its best, but I got it, so that's the main thing. So just a few images of that, and then just to give you your bearings as to where you're looking for it. So this is a wide angle view I took of the comet. So the bright yellow star Capella up there, and the 3 stars here called the kids that help you identify definitely which star that is. And that's all part of Auriga, the Charioteer, which is a kite-shaped constellation. And I think I showed this the other day anyway. So the comet is down here. So this was the comet. So that was on the 6th of July, the morning of the 6th. So this morning it was there. And then by the 11th, it's going to be there. So it's going to be almost in line with these 2 stars. So hopefully Saturday morning, you'll all be able to find it, which is great. And because it's heading north, so it's in that sort of a direction, because it's getting higher, it's actually circumpolar from the northern part of the country at the moment. But of course, don't forget the tail sticking up. So you're going to see the tail all night if you've got a really good northerly horizon. So perihelion was on the 3rd of July. And the closest to Earth is actually on the 23rd of July. So that could be a good anniversary, Alan.
Oh, yes, I've already noted that. So.
You already noticed that, yeah. And
yeah.
It's going to be 103 million kilometres from Earth. And it's going to be easiest at the moment in the morning sky before half.
Is Hale of Hale-Bopp comet.
So it's going to be easiest in the morning before 3:30 when the twilight starts coming in. It'll be different if you're further south or further north. But it's getting higher in the sky. So we'll be able to get it in the evening as well as the morning. So early July, visible low in the northeastern morning sky before 3:30. But because it's getting higher in altitude, for around about the 10th of July, it should be visible in the the northeastern morning sky and the northwestern evening sky as well. So we've got 2 bites of the cherry, so to speak, and it is getting brighter, and it's looking like it's got a nice ion tail as well. So very reminiscent of the other comet. Okay, so just a reminder of the path. Here it is. So it's currently going past Auriga. Here's Capella. So that was the position on the 9th. By the 15th, the middle of the month, it's approaching Lynx. And then on the 23rd of July, when it's closest to the Earth, it's below the plough. So here's the plough, 7 stars of the plough. And then end of the month, it's up in Comet Bennett. So that's the path of the comet. So you know roughly where to look, hopefully.
Dave, has there been any further reports about it breaking up? Because when we spoke Tuesday, somebody mentioned that it possibly might be breaking up. Has anybody been able to sort of verify that?
I haven't seen anything yet. Alan may tell us something about that later.
Right.
Okay. So just looking ahead now to future meetings. I think most of you know these anyway. But so next Tuesday we've got Ian Ridpath talking about pictures in the sky. Oh, they're all in the wrong order. We've got Chris Lintott on the 28th of July. And then the 21st of July and the 4th of August. I thought we'd open those more to you guys to show what you've been up to. So on the 21st of July, we'll talk about webcam, planet and moon imaging. So I'll show you what I do and I've been having a fiddle with some of my old images and trying to improve my processing on those as well. So I'll share some of those. And on the 4th of August, darkened evenings will be coming by then. So really love you to share some of your experiences and images. I've had a couple of people who said they'll do something. So give us a shout and let me know, and we'll pencil you in for that. Okay? So that's what's coming in the future. But of course, today, 25 years ago this August, I was in Portugal on holiday, and we were told there was a new object discovered. So we decided to get the half-meter scope out and take a CCD image of this little fuzzy blob. Yeah, and of course, as you'll know, it's Comet 1995-01 Hale-Bopp. Okay, discovered on 23rd of July 1995 by Alan Hale and Thomas Bopp, and I'm very pleased to say that the comet turned out to be absolutely spectacular a few years after. And tonight's meeting is Alan Hale, who's going to tell us all about comets.
Okay, this goes back, believe it or not, over 50 years. I was 11 years old, pardon me, and I had been interested in astronomy for a long time, and it was, I don't know how many of you are familiar with the television show The Simpsons, but I was doing like a Bart Simpson with Dad, I want a telescope, Dad, I want a telescope, Dad, I want a telescope, Dad, I want a telescope. You get the picture. And he finally relented and got me a small telescope, and lo and behold, there was, not too long thereafter, there was a somewhat bright comet in the sky, Comet Tago, Sato, Kosaka. So on the evening of February 2nd of 1970, I went out and saw Comet Tago, Sato, Kosaka for the first time. That is the sketch I made at the telescope that night. So that is my very first comet observation. And little did I know what was in store for me after that. That comet had been a fairly decent naked eye comet from the southern hemisphere prior to that. And this is an image taken in early January from an observer, I believe, in Australia, maybe Queensland. And it was dim naked eye by the time I saw it in early February. This has the interesting distinction of being the very first comet ever observed from space. The OAO2 telescope had ultraviolet sensors aboard and detected a large cloud of hydrogen around the comet. We now know that that's the Lyman alpha cloud, that's what it's called. And aboard SOHO's telescope, SWAN, the Solar Wind Anisotropies, which is a large ultraviolet telescope, and comets appear in SWAN images all the time. In fact, several have been discovered, including one just a few months ago. This is, if you can see my little arrow, that is Comet Lemon 2019 U6 in the SOHO images. This was just a few days ago. So the SWAN is very good at detecting these ultraviolet clouds. Well, Tago, Sato, Kosaka was the first one. But less than 2 months after Tago, Sato, Kosaka came another comet, and I took a photograph of that comet. This is Comet Bennett, and I guess maybe you were very, very impressed with that image, that photograph. I was 12 years old. It was a handheld Brownie camera that I stood and tried to hold steady for however long, and managed to get a couple of photographs of Comet Bennett. So very, very impressive. That's Comet Lemon and the SWAN images that was taken a few days ago. And then that incredibly impressive photograph that I took of Comet Bennett. You all see that?
Yes, we can. Yes.
Yeah, that's the one that I was 12 years old, handheld Brownie camera taking that picture. Fortunately, there were people around who knew more about comet photography than I did. And this was a photograph that was taken over the Swiss Alps right around that same time. I think if there was anything that really got me hooked on observing comets, it was Comet Bennett. And coming so soon after I had started observing comets, I had got this idea that bright comets come by all the time. Well, we all know how true that is. But ever since then, I have been trying to observe every comet that comes along that's bright enough for me to go out. And 25 years ago this month, that paid off in a very interesting way. This is the sketch I made after I had come across that fuzzy object near M70 in Sagittarius on the early morning of July 23rd, 1995. M70 right there, and you see the little fuzzy object right there. And after 45 minutes or so, I could tell that the object was moving. I had checked, there were no known comets in that location. I reported it right away, and you all know what happened after that. This bright comet that became very brilliant in the nighttime sky a year and a half later, and made my life very interesting for a while. I could sit here and regale you with several of the stories of the various adventures and misadventures that I had over that time. I will just show. Okay, now I seem to have lost my cursor. Okay, now we have it. One of my more memorable occasions observing Hale-Bopp was at the U.S. Naval Observatory in Washington, D.C. You may or may not know this, but the Naval Observatory is where the U.S. Vice President lives. And so we had a private comet viewing session at the Naval Observatory with then U.S. President Al Gore and his then wife Tipper. And it was an interesting experience. Of course, I complimented the Vice President on this nice telescope and observatory that he had in his backyard. And he got a good laugh out of that. Unfortunately, of course, this is right in the middle of Washington, D.C., so there's lots of light pollution, so the skies are really not that great, and they weren't that good that night because we had little thunderstorm cells moving through all the time, although we did have moments of clear sky here and there, so we actually did get to see the comet. So the comet has hung around for quite some time thereafter, and this is, as of now, the very most recent image taken of Hale-Bopp. This is with ESO's Very Large Telescope in Chile, and this was taken in August of 2013. The comet is about 24th magnitude. It's 39 AU from the sun. As far as I know, no one's taken or attempted any images since then. In theory, it might still be detectable, especially with Hubble or some other platform of that nature. I would like to hope someone to give it a try at some point in time. Meanwhile, Hale-Bopp is what I'm known for, but I would like to think I've done a few other things in my life. I've made a few other contributions. I started when I was in high school. When I was in high school, the near-Earth asteroid 433 Eros made a close approach to Earth. In fact, the closest approach is made to Earth since its discovery late in the 19th century. And I did a science fair project on Eros. And this was my display for my science fair project, where I have a log that we spray painted black to represent the asteroid because it's dark, rotating on top of a bird bath pedestal. And I won pretty high awards for my science fair project that year. Of course, Eros has gone on to achieve quite a bit of notoriety. It was the destination of NASA's Near-Earth Asteroid Rendezvous mission, later renamed Near Shoemaker, at the very beginning of the 21st century. So that's one of the images of Eros taken by Near Shoemaker. A year later, after the Eros approach, came what I considered to be the best comet I have ever seen, and that was Comet West. And my project that year centered a lot on Comet West, although I looked at a few other phenomena as well. This was a photograph that was taken by my father from the doorstep of our house in New Mexico when the comet was near its brightest. So anyway, I've never quite seen anything quite like Comet West since then. My one desire in life is I would like to do so again at some point. The one that bears my name was almost as good as Comet West, but not quite, in my humble opinion. Anyway, in the years and so on thereafter, I made kind of started to make a name for myself, observing comets, measuring brightnesses. I was rewarded for this by David Levy and the Shoemakers. They named an asteroid after me. So that is 4151 Alan Hale. And I had this image taken with the Las Cumbres Observatory telescopes. I'm affiliated with them. I work with them. when it was in opposition in June of last year. Now, I had taken 2 images roughly an hour apart, and I was using this as part of an educational program that I'll be talking about here just a little bit. I showed the 2 images to my partner, Vicky, and without the arrow, and see, can you spot the moving asteroid? Can you spot my asteroid? She didn't find it, but she found another moving asteroid in the same set of images right there. That was, I forget the number, it's like 75,518 or something like that. And it was discovered by the Linear program here in New Mexico. It is not named, and I'm trying to see if I can get the asteroid named after her, since she independently rediscovered it, so to speak. But anyway, I guess in theory I could show the other set of images, but I'm just showing the one here. But yeah, that's my asteroid, and that's what I like to think of as Vicky's asteroid right there. I was part of the International Halley Watch in 1986, and I was very pleased and honored to be a part of that particular project. I remember when I first started reading about astronomy when I was in elementary school, and reading about Comet Halley, and it will return in 1986, which was a long time in the future at that point, and figuring how old I would be in 1986, and I determined I would be 28 years old. Well, I took this picture on my 28th birthday. Now, this is on the Listcrest Highway, close to the turnoff towards Mount Wilson Observatory, since I was living in Southern California at the time. Working at JPL, the Jet Propulsion Lab, and I was working with the Deep Space Network, and probably one of my favorite lifetime accomplishments is I was part of the radio science team during the Voyager 2 encounter with Uranus. So I've got a couple of Voyager images. That's Uranus itself. That's Uranus's rings. I was with the radio science experiment and was one of the first people in the world to see the radio signals as the spacecraft passed behind the rings, and we were able to determine the approximate size distribution of the particles in the rings. I was always proud and honored to be a part of that. I mean, yes, it was one of a cast of thousands type of thing, but I'm still very pleased to have been involved. I did go to graduate school of astronomy. I managed to earn my PhD from New Mexico State University in 1992. This is my PhD thesis for anyone who was masochistic enough to want to read it in the Astronomical Journal in 1994. I did my PhD thesis not on comets, but on exoplanets, which at that time was still more or less a theoretical subject. The first exoplanets were starting to be reported right around the time I finished up my thesis, and the first ones immediately showed that my thesis was outdated, but that's kind of the way it is in science. One thing that, I mean, this is kind of a joke, if you can bear a joke here. I always figured one of the best ways to achieve scientific immortality is to have something named after you, like an equation. So somewhere along the line, while running through all the math, I had an occasion to come up with a function which could only be defined by this horrendous integral, and I used a stylized h, and I called that the Hale function. So the only time it ever appears in the literature is this one time in my PhD thesis, but I still like to call that the Hale function. So there it is, if anyone would like to take a look at that. If I could have found a decent employment in the field of exoplanets, I would have stayed with that field because I found it very fascinating. I was unable to do so. My life went into a different direction for a reason you can probably figure out. But one of my colleagues in the field stayed with the field and became involved with the Kepler mission, which was trying to detect exoplanets by the photometric method. He and I had actually written a paper on that. And Lawrence Doyle, who's at the NASA Ames Research Center, was the lead scientist on the team that discovered the first Tatooine-type planet in Kepler data, Kepler 16. This is an artist's conception of Kepler 16, and I was really excited for my former colleague when I saw that he was the lead scientist on the team that made that particular discovery. I was able to get my own CCD imaging equipment. It was donated, thanks as the result of my Hale-Bopp discovery. This is an image of Comet Wield-2 passing by the Crab Nebula in early 2003. Now, Wield-2 is the comet that was encountered by the Stardust mission in early 2004. Now, I took this image just as Wield-2 was starting to disappear behind the sun in solar conjunction. And I shared this image with some friends of mine, and they passed it along. The next thing I know, I was getting contacted by the Stardust Project. Please, please, please get some astrometric measurements from from those images, because we need these for navigation purposes. So, of course, I did so. And for a while, this particular image was on the homepage of the Stardust website. I guess you could say I helped play a part in navigating Stardust to its mission. So I had a part in the success of that mission, and I feel kind of rather proud of that particular accomplishment. Another area that I've gotten involved in, I've gotten involved kind of in the commercial space industry. I live close to White Sands Missile Range, and it was during the mid-1990s that the experimental Delta Clipper DCX single-stage rocket was tested out at White Sands, and I was privileged to go out and witness a few of the DCX launches. So that's a picture of me from back in the mid-1990s, standing in front of the DCX. And from that was born what we now call Spaceport America, one of the world's first commercial spaceports. And this was from a presentation a few years ago. Another part where I'm one of a cast of thousands, and I'm pleased to be listed among that group. Spaceport America is where Virgin Galactic will be doing its suborbital launches when they can get their Spaceship Two to an operational status. Of course, Richard Branson is the whole brainchild behind Virgin Galactic, and I got to meet him once several years ago when Spaceport America was dedicated. So again, that's something I'm very pleased to have been a part of. Even if I was one among many, 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 I'm still was a part of that. But being involved in commercial space got me to meet a lot of interesting people, go to a lot of interesting events. This was a picture taken at the Arthur C. Clarke Gala in 2001. Of course, it would be in 2001 at the Playboy Mansion in LA. And I'm with a very distinguished cast of characters there. That's yours truly right there, looking probably strange in a tuxedo, since I never wear that type of thing, but this was a tuxedo event. But I'm with Buzz Aldrin and Jim Lovell. And back behind me there, that is George Whitesides, who is now the CEO of Virgin Galactic. On the other hand, we have notables like Jim Cameron, who at that time was fresh off the success of Titanic. And he and I had some rather interesting conversations. He told me he someday wanted to make a very scientifically accurate asteroid impact movie. And I said, well, if you need a consultant, please look me up. Little did I know he was actually starting to work on the movie Avatar at that point. Meanwhile, that is Morgan Freeman. And there in back center, the MC of the whole event is Jean-Luc Picard, a.k.a. Patrick Stewart. So it was an interesting group of people all around, and it was fun being part of that particular event. On the other hand, as a result of a lot of the experiences and travels I have had, it's always been impressed that astronomy is such an interglobal, international activity. It's really the same sky that all of us see. And of course, being a child of the Apollo era, I was inspired by the Earthrise image from Apollo 8. And when I founded my organization, I called the Earthrise Institute. I, of course, took the Earthrise image as my logo. Among many, many adventures that I've had is in 1999, there was a solar eclipse that crossed Iran, and I was able to lead a delegation of Americans for a 2-week visit to Iran to, among other things, see the solar eclipse, but also we spoke at a number of universities, mixed with a lot of the people. I made a lot of friends in that country as a result of that trip, and some of them I'm still in contact with. So that's probably, of all the things I've accomplished in my life, that certainly ranks among one of the highest in terms of my personal favorites. I was awarded and recognized for some of these efforts. I was a finalist for a Special Citizens Award that was presented about a decade ago by the U.S. Congressional Medal of Honor Society, and that's my certificate right there. Again, I'm kind of pleased and honored to have been a part of that. I'm still active. I'm not quite the world-famous celebrity I was all those years ago, but I still have some recognition. And I wanted to do something positive, and especially with some of the negative world events going on at this time. And with this year, 2020, being not only the 25th anniversary of the Hale-Bopp discovery, but also the 50th anniversary of my first comet observations, I created an educational online program called Ice and Stone 2020 about the small bodies of the solar system. It's available to anyone, all educators, students, and any interested people around the world. Doesn't cost anything. You can access it. I registered the domain Hale-Bopp.org. It's easy to remember. And every week I have presentations on interesting events that happened in the history of small bodies during this week. I have a Comet of the Week every week. This week it happens to be Comet Tempel 1, which the Deep Impact probe encountered during this particular week in 2005. I also have a special topic of every week where I explore some topic related to small bodies. This week happens to be all the various spacecraft missions that have gone on to the asteroids and comets of our solar system. And I explore various aspects. The small bodies are of interest for a number of reasons. That's how the planets in our solar system were formed. The asteroids and comets we see today are the leftovers of that process. And in the process of building Earth, they delivered water and the organic substances that led to life. And so a couple of pictures that were taken by my partner, Vicky. This was a picture she took of water. I wanted to see a water scene, so she took that water scene when we were visiting Australia a year and a half ago. And this is actually a scene right off the deck of our house. Like I say, we do live in the forest in the mountains. So we've got plant life and trees and grass and some deer that happen to be passing through at that particular time. In a way, we were able to get insights into the formation of other planetary systems. This is Comet Borisov, the interstellar comet that passed through our solar system late last year. And this was an image I took right around the time the comet was closest to Earth. So we're getting insights not only into our formation of our planet and our solar system, but other planetary systems as well. And I seem to, now I got my cursor back. Another reason these objects of interest are that these things impact Earth from time to time. Sometimes every once in a great while, very large impacts like the one that struck Earth 66 million years ago near the Yucatan coast of what is now Mexico, and among other things kind of did in the dinosaurs. Of course, we are here as a result of that particular impact, but we don't want it to go the way of the dinosaurs. So we do have all the various survey programs going on right now. Even though an object of this magnitude only happens on time scales of every tens to hundreds of millions of years, still we would not want to take any chances on that happening to us without our being aware of it plenty of time in advance to do something about it if necessary. We still have smaller events that happen from time to time. I'm sure most of you remember the Chelyabinsk Meteor, which landed near Chelyabinsk, Russia 7 years ago, and is thus far the biggest impact event on our planet since the beginning of the 21st century, which tells us that these smaller objects, which I think are probably the ones we need to watch out for the most because they're much more frequent, and even though they don't do global damage, they can certainly do damage and cause casualties over a regional area or local area. So we will always be kind kind of on the lookout for these types of objects. Another thing that reason, and I think even perhaps even a more important reason in the long run, that these objects are so important is because they contain resources that we can use here on Earth. I mean, a metallic asteroid contains enough resources, especially in terms of metals, to be worth trillions of, well, I'm an American, so US dollars, but pounds or euros, depending on what kind of currency you want to talk about, that we can use. Now, of course, there's a huge investment and infrastructure necessary to make this type of thing happen. But I think this would be a good intermediate range for our focus. Is let's start seeing what we can do to access these asteroids and access the resources they contain. Because the supply, perhaps while not infinite, is so much more so than what we have available on Earth. For a while, I was actually on the advisory board for one of the private companies, Deep Space Industries. DSI ended up kind of being bought out by another broader space company about a year and a half ago. But for a while, we were, DSI was actually looking at developing different spacecraft ways to scout and eventually set up operations on mining for some of the near-Earth asteroids. I just kind of threw this picture in there. Several years ago, space artists painted a special painting for Earthrise. He did it basically for me free, said, here, I'll do this painting for you. You can auction it off, do whatever. I still have it. I'm looking for donors for that and some other projects. So if anyone is interested, or someone is interested, please send them my way. Meanwhile, life has settled down for me. It's a kind of a quiet life for me now. I hate to admit it, but I passed the magic 6.0 a couple of years ago. This is where I live. I live up in the mountains, up in the forest. I'm at an elevation, 2,200 meters. We do get winters here in the New Mexico mountains, so this was kind of a wintry scene that took picture here within the fairly recent past of just the area where I live. I have a great lady in my life named Vicki. We met about 3.5 years ago, and she moved in with me about 1.5 years ago. She puts up with me. She even gets up, like she's going to be getting up at 2:30 tomorrow morning to go observe Comet NEOWISE with me. And so, give a shout out to Vicki. She's not here right now. I have a picture of Vicki that was taken in her teens where she looks great in a pair of hot pants. And I was threatening to show that picture as part of the presentation. She said, "Don't you dare." So, no, I won't do that. But anyway, that's the lovely lady who puts up with me. I keep having this fear that she's going to come to her senses one of these days and run screaming for the hills, but she assures me that won't happen. I had 2 young sons during the Hale-Bopp era. They're not young sons anymore. They are fully grown young adult men. That's Zachary and his partner, Karina. They are actually living in Australia, near Adelaide at this point. Karina is working on her doctoral program. That is my other son, Tyler. This picture was taken a couple of years ago. This is a more recent picture of Tyler and his partner, Sarah, and her daughter, Avery. That is the closest thing I have to a grandchild right at this point. So anyway, but time goes on, life goes on. I sometimes am amused as people still remember Hale-Bopp. This is a question from the American quiz show Jeopardy that was here within a fairly recent past. And we got a good amusement out of that. I still observe comets. I'm still out there most nights. I was out there last night observing comets. If you go to the Earthrise website, which is earthriseinstitute.org, and go to the Comet Resource Center, you can learn all about the comets I'm observing, where they are, how bright they are. There are various links one can click. You can, this is, descriptions list where they are right now, how bright they are, and so on. Some of the more interesting ones that are going to be coming in, and so on. We have an interesting comet in the sky right now. Dave was mentioning a little while ago, Comet NEOWISE. This is an image I took of Comet NEOWISE back in April with one of the Las Cumbres Observatory telescopes. That time it was still a relatively dim object, but it was, of course, on its way in. Dave already showed the movies, but this is one of the still frames from one of its passages, or as it was passing through the field of view of the C3 LASCO coronagraph aboard Soho late last month. And I went out one morning last week to observe it. I had telescope problems. I wasn't able to get my camera set up, but the comet's gotten higher in the sky, and Vicki and I are going to be going out tomorrow morning, hopefully, if the weather cooperates, and it's supposed to. And I'll get some good images then, I hope. But in the meantime, in the lack of any images I have a couple of others. This one, it was taken from the International Space Station a few days ago. And Dave, I think you will recognize this image that I swiped. You showed this very image here a little while ago. So that's what the comet looks like now. And at least that's what I hear anything, and I'll be able to verify this for myself tomorrow morning, I hope. There's some other comets that are on the way. This is Comet Pons 2017 K2 that was discovered over 3 years ago out at 19 AU from the sun. It doesn't reach perihelion until December of 2022. It's still a somewhat distant 1.8 AU, but it's so intrinsically bright that it should be a relatively easy naked eye object. How bright it's going to get, I don't know. I personally don't expect it to get any brighter than about 4th or 5th magnitude, but I could be wrong about that. Bad news is not only does it stay somewhat far from the sun, it stays far from Earth. It's badly placed around the time of perihelion, and of course, it's only visible from the southern hemisphere, which is the way most of these things work. I'm glad that NEOWISE is at least providing an interesting exception to that southern hemisphere rule that we seem to be going. And this is Comet Pons Brooks, which is another Halley-type comet with an orbital period of about 70 years that will be returning in the year 2024. It was just recovered last month with the Lowell Discovery Telescope at 11 AU from the sun at 24th magnitude. And so this is a comet that's on its way in. Another Halley-type comet, famous one, Comet Olbers, passes perihelion just 2 months later. So we'll have both of those comets in our skies a little less than 4 years from now. We have an interesting event coming up, just another future event. The near-Earth asteroid Apophis will be passing within the orbit of the geosynchronous satellites on April 13th of the year 2029. That happens to be a Friday, by the way. And your part of the world will get it better than my part of the world. It'll be, that happens during the daytime hours here. So we probably won't miss that unless I feel like traveling, which I probably will not do. I don't travel much more these days. How much longer I keep this up, I don't know. I'm feeling the weight of years a little bit. But in the year 2061, when I'm 103 years old, if I'm still around then, Halley's Comet will be around again to observe. So Vicki missed it when it was around in 1986, so I've promised her that if we're both still around in 2061, that I will show it to her. We will just have to wait and see about that. And with that, I think I'm done.
Fantastic. Thank you very much, Alan. Great insight into comets. So anybody got any questions for Alan?
I've got one, Dave, if I may.
Yep.
Alan, with all the work that you're doing on photographing comets, how do you think the 42,000 estimated satellites from the Starlink's going to affect future viewing of small astronomical objects?
That's an interesting question, and I don't know quite what the answer to that would be. For satellites, generally are most interfering either early in the evening or late in the morning during, or after dusk and before dawn, because that's when they're still reflecting sunlight. I know Elon Musk with SpaceX has been addressing this issue with astronomers and has promised to use darker paint for the satellites, but they're still going to be reflecting. And I've already seen some images that show the satellite trails passing through them. It's probably not going to impact things in a positive way, is probably the best way I can phrase that. How significant an impact it will be is something I guess we're just going to have to see.
Yeah, it's just one of those things. I've seen a few sort of images now where you've got line upon line upon line crossing across your field of view, and it just makes you wonder when we've only got hundreds up at the moment. When we do get to the first 12,000, I think, on the first leg, and then hopefully up to 42,000. I just feel that the global regulation of satellites.
Yeah, I'm afraid you're probably right. Like I say, it's not going to be a positive impact. That's for sure. How negative the impact is remains to be seen.
Well, thanks for that, Alan, and I really enjoyed your talk as well.
Thank you.
Anybody else got a question?
Could I ask one?
Yeah, go ahead.
Eddie Carpenter. Alan, is your comet due to return many years in the future? Is it a period comet? Has it been?
Yeah. As a matter of fact, yes. It has it came in with an orbital period roughly around 4,000 years.
I'll make a note of that.
And it passed close to Jupiter on its way in, and that shortened the orbital period down to about 2,400 years. Now, there was an orbital study published about 3 years ago where we've got now an arc that dates from 1993, when the first prediscovery images were identified, through 2013. So we've got a 20-year arc now. And the authors of this paper predicted next perihelion of Comet Hale-Bopp will be on August 6th in the year 4393.
Right. Long time to wait, I'm afraid.
Yeah, no, I mean, I would take that date with the proverbial grain of salt, of course.
Pinch of salt, yeah.
But, I mean, that's probably at least the right time frame. And what is interesting for me is that, assuming that there is still a human civilization at that time, I'm not sure I would take bets on that, but regardless. But if there is, those people at that era may very well know that that is Comet Hale-Bopp, which kind of gives me a form of immortality that very few people ever achieve.
Right, thank you.
You're welcome.
Excellent. Anybody else got a question for Alan?
Yeah, I've got one, Dave. It's Hugh Allen here.
Yeah, hi Hugh.
Hi, Alan. That was a great talk. Thank you very much. I do spectroscopy as part of my amateur astronomy, and I haven't had a chance to take the spectrum of Comet NEOWISE yet, but probably one of the top amateurs in the country, Robin Leadbeater, has done a simple spectrum using a star analyzer, so no slit. And what he found was that the spectrum is mostly sodium emission. So he's called it a golden comet, which is apparently quite rare, because normally comets are sort of blue-green because of carbon emission, the swan bands. Do you have any kind of comment on that?
None really. Yeah. I've read that people have kind of detected kind of a golden hue.
Yeah.
Those who've been able to see it in the morning sky. Hopefully, I will have a chance to verify that tomorrow morning. I mean, Hale-Bopp actually exhibited a tail that was made up of sodium atoms, so
Okay.
it's not an unheard of
Interesting.
phenomenon, but I think it is rather rare.
Yeah.
I'm not knowledgeable enough to say how rare it is, to be honest with you.
Okay. No, it's interesting. Okay, thank you.
Yeah.
John's asked on the chat, what's the average lifespan of a comet? But it's like a piece of string sort of question, isn't it? Because it varies from comet to comet, I guess.
Yeah, it depends on how frequently it visits the sun, how large it is to begin with. Ecke's comet, the one that's got the shortest known orbital period, every 3.3 years. And by the way, it is now visible in the evening sky from the southern hemisphere. Was discovered in the late 18th century. Has been seen. It was discovered 3 or 4 times before Johann Encke was able to verify that it was all these comets were one and the same. But ever since the early 19th century, it's been observed on every return except one. So it's been making repeated visits around the sun all that time, and who knows for how long prior to that. It does seem to be getting dimmer, so it may not last too much longer. Although if you read papers from, say, the 1960s, 1970s, it was expected to have disappeared by now, and yet it's still around. So, on the other hand, we've seen other comets that have disintegrated as they're coming in. One of the most recent Swan comet, in fact, disintegrated as it passed through perihelion. This was at the end of May. The inbound Comet Atlas did the same thing. So it varies from comet to comet.
Yeah. Of course, we learned a lot from the Rosetta and Philae probes, didn't we?
Oh, absolutely.
On Comet 67P, which is absolutely wonderful. You mentioned this Comet Pan-STARRS that's coming in and could be quite bright in 2024, was it?
2022.
Oh, 2022. Yeah. So the problem is sort of predicting, isn't it? Because though we find them far out, they seem to have lots of volatiles which burn off, sort of come off very quickly, and then they fade again. So are we confident in the prediction that's going to be quite bright?
Yeah, that especially seems to be true of comets making their first visit in from the Oort cloud. They get these outer volatiles that become active at a large heliocentric distance. We think there's something bright coming in, and then lo and behold, they're not as bright. Comet Kohoutek from the early 1970s is the most infamous example of that. Although compared to some other comets, Comet Kohoutek was not that poor a performer. Pan-STARRS is a first-time visitor from the Oort cloud, seems to be. One of the nice things about Comet NEOWISE is that it appears to have been around at least once before, and the same thing was true of Hale-Bopp.
Yeah, John's asked a question as why did the southern hemisphere get all the bright comets?
That is a very good question, and as soon as somebody figures out the answer to that, I think there's a lot of us northerners that would appreciate knowing the answer to that question. We can sit here and take a little bit of joy in the fact that Comet NEOWISE is a northern hemisphere comet, but that's they've been few and far between us. I mean, Hale-Bopp was also primarily a northern hemisphere comet, but the two great comets since then, McNaught in 2007 and Lovejoy in 2011, were both exclusively southern hemisphere.
Yeah. But is it the Koitz comets? That's a family of comets that always have the similar path, don't they?
Right, and they're apparently fragments of a larger comet.
Much larger comet, yeah.
Probably cascade fragments. And the orbital path of the Koitz sungrazers definitely favors the southern hemisphere. And depending on when they pass perihelion, they can become visible in northern hemisphere. Ecke in 1965 was a pretty prominent object in the northern hemisphere. Little before my time, I was alive at the time. I was 7 years old. I'm a little surprised that my dad did not wake me up to see that, because he was normally up at that time, and he knew I was interested, although at that particular time I was going through my infatuation with dinosaurs. So
we've got a couple of more questions on the chat, Alan. Someone's asked, Malcolm's asked, would you say that this long period without a spectacular comet like yours is unusual? So are we going through a particularly barren patch at the moment?
It's random. On average, great comets, of course, great comet itself is a matter of definition, come by about once a decade. And one could argue that that's been kind of what we had. I mean, we had Hyakutake in 1996 and Hale-Bopp in 97 coming, one right after the other. But then it had been 20 years since the previous great one, which was West in 1976. McNaught was 1 decade after Hale-Bopp, but of course that was strictly a southern hemisphere comet, unless we were able to see it during the daytime when it was brightest. If you were knew how to look for a comet in the daytime, it was bright enough to see during the day. But then when it became visible at night, it was strictly a southern hemisphere. And then of course Lovejoy was only 4 years after that. That was another strictly southern hemisphere comet. So the northern hemisphere has certainly gone through kind of a dry spell. We've had some sort of bright ones here and there, but NEOWISE is probably the brightest comet that the northern hemisphere has had since Hale-Bopp.
Good. John's also asked, what's the largest comet ever observed?
Largest is, that's kind of a hard one to answer, because how bright they get can depend upon how active their surface is and all that. Intrinsically, the brightest comet ever seen was a comet that was observed back in 1729. It was Comet Sarabat. And it was dimly visible to the unaided eye, about third or fourth magnitude. However, it had a perihelion distance of 4 AU. And to be that bright at that distance is very remarkable. The second brightest comet intrinsically is that one that bears my name. So I did manage to discover a fairly bright and large one. It never came close to Earth. If Hale-Bopp had come as close to Earth as Comet Hyakutake had come the previous year, it probably would have been the brightest comet in all of recorded history. And the nice thing is that its orbit actually does come that close to Earth. And had it come 4 months earlier, it would have been at that point, at the same point that Earth was nearby.
That would have been exciting.
Yes, it would have been.
That would have been, yeah. Excellent. Okay, any more questions for Alan? Oh, someone said, any comments on Comet Holmes with its sudden outbursts? We all remember that one from a good few years ago, and we had a good, glorious run of clear nights to watch it expanding, which was fantastic.
Yeah, that was a surprise. Now, of course, it was discovered during a similar outburst in 1892. In fact, it was discovered from London. Mr. Holmes was observing from London. Probably can't observe much from downtown London these days, I would suspect. But the late 19th century, it was still probably doable. Then it faded away, and in fact, it was lost for several decades and then recovered again in the 60s as a very dim object and returned regularly as a dim object. And then in 2007, it was still a dim object, and then it had that huge outburst. In fact, that's the largest outburst that's ever been seen on any comet. A rather conspicuous naked eye object, although it didn't have any sort of tail. It was just a large coma. But nevertheless was pretty bright for quite some time.
Nick Hewitt said he could see Holmes from Piccadilly, so there you go. It was observable from central London. Yeah.
I don't doubt that.
Brilliant.
Yeah.
Okay. Any more questions for Alan? No?
No.
Okay, well, Alan, thank you very, very much for giving up your time and giving us an insight into the work you do on your comets. I'm going to put your Ice and Stone and the Earthrise Institute links on the Virtual Astronomy Club website. So I have access to that. So, yeah. So, just one last call if anybody got any questions for Alan before we go. Okay, well, Alan, thank you very much giving up your time this afternoon, because it's afternoon there. And
Thank you very much, Alan.
everybody for turning up and making it a success.
Alan. Appreciate it.
Yeah, thank you. Excellent. Lovely talk.
Be safe.
Nice to hear from you.
Thank you.
Thank you.
Yeah, thank you, Alan.
Good night,
Thank you.
Alan.
Yeah, thank you all for having me on.
Thanks,
That's
Alan.
great. Thank you very much, Alan. Really appreciate it. Okay, you know what I'm going to say, folks? Keep safe, keep well, and keep looking up. Get a look at the comet at the weekend.
Keep looking up.
Don't
Yes.
miss it.
Bye.
Okay, see if you can see the eye on tails. Okay.
Oh,
Bye, folks.
bye.
Cheers. Bye. Bye.
Bye.
Bye now.